Hi, all. This is lecture 20 on section 5.5, properties of logarithmic functions. So I know logarithmic functions are new to you, or relatively new, but they have some really nice properties, and this is why we like to use them in calculus for various things. And those properties are right here. So anytime that we are taking the log of two things that are being multiplied together, we can split them up and give each one their own logarithm, and we can do that by adding, right? Notice that this is addition, right? We kind of think of logarithms are kind of like exponents, and when we have two bases that we multiply, we add the exponent. So that's what we're doing here. Similarly with division, when you were dividing two things, you can split that up as well. Each one gets its own logarithm. The thing on the top is positive. The thing that's on the bottom, or the term that's on the bottom, is negative. Okay, and then the last one, when you have a power, that power can come down in front as a multiplier. And this one seems a little bit odd, but is actually related directly to that first one. So if we think about finding the log of x squared, right? Well, the log of x squared, this is just the log of x times x. And we know that we can separate that using property number one as log x plus log x, right? Each one gets its own logarithm. We add together. And those are just two logs being added together. So that's 2 log x. So you can see that 2 that once was in the exponent is now a multiplier. So it is directly related to that first property. Okay. But we're going to use these. We're going to use these to expand things. We're going to use them to collapse our logarithms, and then maybe even to solve. Okay, so let's take a look at what that's going to look like. So example 1, we want to express this in 4 different terms. We want to have something with a log x, something with a log y, something with a log z, something with a log w. So the first thing I'm going to do is I see division here. I see the top divided by the bottom. And so I'm going to split this and give the top its own logarithm and the bottom its own logarithm. So this is going to be equal to the natural log of x cubed y minus, because it's division, the natural log of zw to the 5th. Okay. Now, each of these two pieces has something being multiplied in it. So I have a first term and a second term, a first term and a second term. So each of those I'm going to split using addition. So this will be the natural log of x cubed plus the natural log of y minus. Now, there's more than one term coming, so I'm going to use parentheses here. The natural log of z comes next, plus, because they're being multiplied, the natural log of w to the 5th. Okay, from here, I'm going to take this negative and distribute it. So that's going to give me the natural log of x cubed plus the natural log of y minus the natural log of z minus the natural log of w to the 5th. Okay, and then the very last thing I do is take care of those powers. So I've got a 3 and a 5, and those are going to come down in front of each term. So it's going to be 3 ln x plus ln y minus ln z minus 5 ln w. And that's what I want. Okay. Now we can do the exact same thing, but in reverse. So I can take a big string of logs, like you see here in example 2, and I can collapse them back together and write in terms of one logarithm. So the first thing I'm going to do is I'm going to undo the last step that I did up above, right? So in the last step up above, I brought down the exponents. So this time I'm going to put those exponents back up. So I have a 3 out front over here and a 2 over here. So I'm going to put those up as powers. So this is going to become the log of xy cubed minus the log of y squared minus the log of x over y. Okay. Okay, now this is not necessarily the way I did in class, but I think it's actually going to be clearer. So what I'm going to do is I'm going to take this one over here, this division, and I'm actually going to expand that one out before I put it back together. Now over here, I'm going to go ahead and distribute that 3 on the outside and make it x cubed, y cubed. They each get a y. They each get a cube. Log y squared. And I'm going to make this log x minus log negative log y. Here we go. This minus is this minus. And then I'm going to do another negative because this y is in the denominator. Okay, so negative, negative, log y. Okay, and so that actually ends up going to be positive log y. Okay, and so now anything that's positive is going to go in the numerator. Anything that's negative is going to go in the denominator. So this will become the log of. The x cubed, y cubed is positive, so it's going to stay in the numerator. The y squared goes in the bottom because it's negative. The log x, so the x goes in the bottom because that one's negative. And you have plus log y, so that y goes up top. And then we can go ahead and simplify the expression inside. So these two y's become y to the fourth, so that's x cubed y to the fourth. And we have an xy squared on the bottom. And then we can cancel whatever we can. So I have one x on the bottom, so this will become a 2. And I have two y's on the bottom, so that will become a 2 as well. So we're going to end up with just x squared, y squared in there. And that's as simple as I can make it. Okay. All right, now be careful because notice that we have rules for multiplication, division, and powers. What we don't have rules for are addition and subtraction. You cannot expand the u plus w and the u minus w. You cannot distribute the log to those things. They have to stay just as is. Okay, so watch out for that. All right, now here's what we want to do to be able to use these properties to solve things. Okay, so notice I have 3 separate logarithms. In order to set things to solve this, I need to have only one log on each side. So what I need to do is I need to take these two over here and put them together. So this is going to be, I'm going to leave the log base 2 of 2x minus 3. Remember, there are no properties when it's subtraction. But over here, I'm going to put this back together. And the 24 is positive, so it goes on top. The log 3 is negative, so the 3 goes on the bottom. Okay, and then this is log base 2 of 2x minus 3. And 24 over 3 is just 8. Okay, now that I have one logarithm on each side, I can take their arguments and set them equal to one another. So 2x minus 3 is equal to 8. Then I can solve. So add 3 to get 2x equals 11, and divide by 2 to get x equals 11 over 2, which is the same as 5.5. Now you should check to make sure that it works out properly. So if I plug in 5.5 and I double it, that's 11. 11 minus 3 is positive 8, and that is something that I can take the log of, right? Because it's greater than 0. So I'm good with 5.5. Okay. So we can use those properties in order to solve. Same kind of thing here. Now, the difference is that this one doesn't have a log, okay? So what I'm going to do is I'm going to move all the logs to one side and all the non-logs to the other side. So that means I'm going to add the log of x minus 2 to both sides. So that I have log of x plus 3 plus log of x minus 2 equals 1. Okay. Then what I'm going to do is put these logs back together. So they're being added. So when I put them back together, I put them back together with multiplication. So x plus 3 times x minus 2 is equal to 1. And then I can rearrange this. Now, when we solved before, if there were logs on both sides, then I set the arguments equal to one another. When that's not the case, I have to rearrange this. So the base here is not written, so my base is going to be 10. My exponent is what's sitting over here, so 10 to the 1. And that's equal to the argument of my trig function. So x plus 3 times x minus 2. And 10 to the 1 is really just 10, so I can get rid of the power, okay? So now I have this, so I'm going to go ahead and expand that. So 10 equals x squared plus 3x minus 2x minus 6. And this is quadratic, so this is plus x minus 6. And I'm going to set it equal to 0, so I'm going to subtract 10 from both sides so that I can solve. So x squared plus x minus 16. And now I'm looking to factor this. Two numbers that multiply to negative 16 but add to positive 1. I don't think that's going to work because we've got 4 and 4, we've got 2 and 8, and that's about it. So let's use quadratic formula here. So your A is 1, your B is 1, and your C is negative 16. So quadratic formula tells you negative 1 plus or minus the square root of 1 minus 4 times A times C. So that's 64, but with a minus it becomes a plus, over 2. So this is negative 1 plus or minus square root of 65 over 2. Now we want to be careful here because this gives us two answers. We have the positive version and we have the negative version. Okay. Now, if I were to take negative 1 plus the square root of 65, the square root of 65 is about 8, a little more than 8. So if I add negative 1, that's going to be 7 something divided by 2. That's a positive number. That one works. But over here, when you have negative 1 minus something like 8, so negative 1 minus 8 is going to be negative 9 divided by 2 is negative 4.5. That's going to give me a negative value, and I can't take the log of that. Well, hold on. Because when I take the log of that and I plug it back in up here, if I subtract 2 from a negative number, that's going to be negative, and I can't do that, right? Now, if I take that number and add 3, let's see what they are. Okay, let's forget estimating. Let's figure out what they are, right? So 1 plus square root of 65, negative 1 plus square root of 65, divided by 2. This turns out to be 3.53. And the negative 1 turns out to be negative 4.53. We know this one can't go because if you plug in the negative here, negative minus 2 is negative, and you can't take the log of a negative number, okay? The positive one, does the 3.53 work? Well, if I take 3.53 and add 3, that's positive. I can take the log of that. And 3.53 minus 2, that's positive. I can take the log of that. So we're good with the 3.53.